Hi, my name is Ken Lasseson. It is October 19th. I've done a rework and update of a set of pages called EndProducts, which are on the website now. First thing I want to do is walk through what I'm doing, what it means, and then show you how it may be able to assist you in understanding what the nature of some of the problems may be. So the first thing is that from PubMed and other sources, I have assembled a list of bacteria which produces a variety of end products, for example, dopamine, bile, biotin, cellulose, etc. So if you are interested in a particular thing like serotonin, click here, and the bacteria which I've been able to identify in PubMed articles are listed there. And by species, if there are strains, then they are also a strain. Notice that this list is an ongoing work in progress. If you happen to discover an article stating that a bacteria produces serotonin, check the list. If it's not on the list, send me a link to the study so I may update the list and everybody can benefit from that update. So what I now do is from this list, I look at the results of your sample, and anytime there's a match, then we count in the number of bacteria that you have matching. Suppose you have 100 being reported of fragilis, another 1,000 Hafnia. I would add those together to get a grand total of 1,100. Although different bacteria produces different amounts of substances, we don't have that data easily available and relative to each other, particularly almost unseen up. So we end up assuming that one bacteria cell produces one unit of bacteria. We know it's wrong, but without a better information being available from public studies, there's nothing much we can do but punt. So that gives us how we calculate some magic numbers. Now we can go over, and if you take a look at end products, we will now see that for each thing we'll have shown below a chart of how much, what the count is of other people in our sample base. And it goes from 0 to 100, being that this range here is for the bottom 10%, this range here is for the top 10%. But because some cases only a few bacteria are associated, some people will have 0, which creates a side problem. And the result is I simply declare, for example, for this one, we have just 19 samples out of 981. So most people don't have the bacteria which we have it. Not that they don't have the bacteria, their microbiome report doesn't cover these bacteria. So the result is we get 0. You may have them, just not in your microbiome report. So anyone with a low percentage, generally don't pay much attention to. It's there for the sake of completeness. We go over to something like acetic acid. We find that it's 97%. In other words, almost everybody has some of the bacteria, and you can see the relative proportions here, and you see a few people have a very high amount of it, and some people have some of the bacteria, but not very many of it. So that shows you how the charts are put together, and we only looking at cases where we have at least one of the bacteria being reported. There's a whole bunch of philosophical, statistical discussions we can get into, but let's skip that for the moment. I just wanted to make sure I've declared that one. Again, here we have a nice bacteria associated. If you click OK here, it will go over and give a list of all of the bacteria, and you can scroll down or up to your heart's content. The downside is that frequently we have the microbiome tests do not necessarily report on each and every one of these bacteria. So there's a absence of definitive information. Now, the next one over is the Symptom Explorer. And the Symptom Explorer is like the Taxonomy Explorer. It allows you to go in, select a particular characteristics. For example, let's do forgetfulness and apply the choices below. And we now see the results of the analysis. In this case, I happen to automatically click into one of my samples, which was one sitting in memory, and it automatically picks it. And what you can see here is some interesting thing. You have a large number of things with very high things, especially if it has an E after it, then the probability of happening around time is very, very low. And those are the ones you should pay a lot of attention to. And what you can see is that sometimes you can get some pretty defined patterns, like L-tryptophan. People who are very low producers of it ends up being where the statistical significance is. Similar here, a lot of the forgetfulness ones are from low producers. However, we also find people who have a large number of sulfite rather than sulfate producing bacteria are associated with the forgetfulness, as well as hydrogen sulfide producing. And we have a couple of other things. So it's done, and as with the taxonomy Symptom Explorer, we go and proceed to break it down into finer and finer details to see it. And when you get down to the bottom, you see some things are pretty impressive, as in the people who have very little of this one, 51. We expect eight in each one of the cells here, and there's a whole stack of people sitting down at the bottom. Again, we are comparing it to the people who have some being reported, and we're using the tables which we looked at a few moments ago for our reference. So the fact that you're down the bottom means you're in the bottom of 10% of the measurements. Okay, so that's basically it. If you go over to change samples, you can go down and you'll see the EndProducts Symptom Explorer sitting there. If I click one, it will take that particular taxonomy, go take it over. I'm going to go and see if I can try something. I'm going to try my age group, because that one happens to be a very strong run for taxonomy. Let's see what happens here. And what we have is, don't have as good as match as we do with taxonomy, but we do have a fair number of matches, and more importantly, indicates what tends to happen in this age group. For example, formate, we as a group tend to be much lower than other things. In butanol, we tend to be much higher than other people. So it gives you relative comparisons, and the same thing as before. Okay, so that's it. It is all experimental. The accuracy is being driven by two things. One is the list of bacteria, which I can identify in the medical literature, which is incomplete. Second factor driving it is the bacteria which are being reported on by the microbiome sample, which is again incomplete. So we have two incompletes, and what we have here is a trying to work with the best information we do have available. It's incomplete, it's not correct, it's not definitive, but it's better than having no information, which is usually my criteria. I'd rather have some information which is fuzzy than no information at all. Better probability than axiomatic beliefs. Okay,